But once you've gathered all that information, you can execute this code, this DSL code, in one context and execute this method called create table. And what this method does is walk through each one of the fields that you have created through these property settings and generates DDL to create the table structure for this relationship. Notice this is the advantage of declarative code, because nothing in here says anything about, oh, I'm going to create DDL from it. All I'm doing is talking about the relationship between these objects and letting the context produce the DDL. But if I execute this exact same DSL in another context, it can actually create what is another DSL. This is one called DOT, which is from the open source GraphViz library. And what you do in DOT is describe the relationship between things as arcs and lines. So if you execute this DSL code in another context, it produces an ER diagram for you. This is one of the really nice things about writing declarative code, because writing imperative code means that you are tying what it does into the definition of the code. Writing declarative code means that you declare your intent, and executing it in different contexts can yield different results, like DDL, like regular data transfer objects, or like ER diagrams. Up until now, I've been talking primarily about internal DSLs. And that's where most of the work in the DSL world is happening right now, is in internal DSLs. Let's talk about external DSLs for a second. And this is basically the situation of rolling your own language. There are some really old school ways to do this that you probably encountered at college at some point, like Lex and Yak. And Lex and Yak really is bearskins and pointy rocks. Because there are much better ways to do this now. There's a really nice open source tool called Antler that makes it easy to create your own language grammar and then produce the code that actually does something with it. It's all open source. In fact, it even has a grammar IDE for you now called Antler Works that gives you code insight for creating your grammar. It helps you syntactically what a grammar looks like. It'll even show you diagrams of things like what the relationship between these keywords are and what gets called next. And what's kind of interesting about that is, you know what Antler Works uses to produce this diagram right here? GraphViz. You have to have GraphViz installed before this thing shows up. And that's pretty much been the state of the art of external DSLs for a long time, which is one of the reasons we're so heavily invested in XMLs. It's kind of hard to write your own lexer and parser, and it's scary, and it doesn't seem like a good use of time. And that's pretty much the state of the art in external DSLs until about now. Because a new category of tool is coming out called a language workbench. And there are several of these that are under active development right now. One of them is from Intentional Software and Charles Simonyi. Now, Charles is famous for two things and infamous for one thing. Does anybody know what those things are? Surely somebody knows. Hungarian notation is the thing that he is infamous for. He actually got kind of a bad rap on that, but he is always associated with Hungarian notation. He's the guy who created that. The other thing that he's famous for, he was the chief architect of both Word and Excel within Microsoft. And the other thing that he's sort of famous for is last year he took a vacation in space. He went up to the space station. In fact, I heard just a couple of weeks ago he's going again next year. Because what happened with Charles, he was a Microsoft employee, of course had lots of money because he was the creator of Word and Excel. And a few years ago, he went to Microsoft and said, I'm really into this whole language workbench idea. And they said, nah, we're not that interested in that. So he did what any self-respecting Microsoft employee would do. He took his billions of dollars and he stomped out the door and he started his own company called Intentional Software. There's only one problem if you're a multi-billionaire and you own your own software company, deadlines, they don't mean that much. Because Charles has really, really hard decisions to make, like, should I work on intentional or should I take a vacation in space? I don't know. That's a tough question. He has problems we can't even imagine. He has a full-time helicopter pilot. And somebody I know was talking to the helicopter pilot, and he said, yeah, my job was really easy while he was training to go to space, so I was just sitting around. So he has a full-time helicopter pilot, just sits around until he wants to go somewhere in a helicopter. In fact, somebody said they invited him to a dinner party, and they got a call about 2 hours before the dinner party, and they said, where's the closest place near your house where we can land a helicopter? So he has really hard problems. Like, where am I going to land my helicopter? So they've been working on intentional software for years, but they won't show it to anybody. They will let a few people see it, but you have to sign a non-disclosure agreement. And it's what I refer to as the unforgiven NDA. How many people here saw the Western movie with Clint Eastwood about 8 years ago called Unforgiven? Anybody see that? There's a scene in that movie toward the very end where Clint Eastwood's trying to escape, and he tells the people in the town, he yells out, if anybody takes a shot at me, I'll come kill you, kill your wife, your family, and your dog, and burn your house down. That's what the intentional NDA says in legal terms. Because apparently Charles can afford lawyers. So it's either going to be really cool when it comes out, or it's not going to be that interesting. But nobody knows until they actually produce something, but they keep talking about producing something, so we'll see. In the meantime, Microsoft has also gotten interested in this area, and they actually have two initiatives going. One is around software factories. The other is around the Oslo stuff that they're just coming out with in a couple of weeks. That also has some DSL stuff in it. But the one I'm going to show you is one by the guys who created IntelliJ, JetBrains. And it's this tool that they're going to call MPS. And in fact, they're going to release a beta of it in a few weeks, and early next year they're going to open source it, which is really going to irritate Charles because he's going to charge money for his, and the JetBrains guys are going to open source theirs. So let's talk about what a language workbench is. Ever since you were in Computer Science 101, this is what your relationship to code has looked like. There's an editable representation, which is a source file of some kind, and that's also your storage representation where you can version and all that other stuff. You compile it into an abstract syntax tree, and then some other tool takes that and produces an executable representation from it. So your source code becomes an abstract syntax tree. But there's a category of tools that Martin Fowler refers to as post-IntelliJ IDEs. IntelliJ was the first IDE that lets you edit the syntax tree directly. That's how refactoring works. Refactoring is not a big search and replace exercise. What it does is modify the AST and then regenerates the code based on the AST. And that's what language workbenches do. They shift the focus away from text to directly into the AST. So you can have projections from the AST, and those projections might be a text file, but they may also be a graphical representation of something, like an ER diagram, or it could be some sort of a form that has properties and events and that sort of stuff on it. And there's a way to version it, and there's a way to produce an executable representation from it. And that's the idea behind these language workbenches. And here's an example, a couple of screenshots from MPS. MPS creates DSLs based on this idea of a concept. So a concept is a very low-level thing. In this particular DSL, you see dates, and a date is a concept, meaning that a date knows that it has year, month, and day, and it knows that those are all numeric values. And you also, when you define the concept, define a way to edit that concept. So you create an editor along with the concept. And so this particular example shows several different concepts. One is a date, one is an account, one is an amount. An amount is a dollar figure, which can either be numbers, or it can be constants, or it can be a formula, but they all yield a date. And all these go together in a concept called a plan, which this one is called the regular plan, the regular rate plan. So what this is the rate plan for usage and service calls and tax for date ranges.